Hello everybody. I'm going to make a quick little video here to get you started before you start jumping into the more complex aspects of Lewis structures and covalent compounds. I'm going to do a couple of examples, just going to talk you through how to create a covalent compound. And just remember that let me go ahead and add a slide here. Number one, use same guiding rules as ionic regarding electrons. And that means that noble gas. Everyone's trying to look like the noble gas, so use the same guiding rules. It's not a different game. The second one is electrons will be shared rather than transferred. Okay, so really this is the only difference, is that you're going to end up showing some way that you're going to share, but drawing the Lewis structure and how that's done and the rules for everybody being happy with an octet looking like the noble gases is the same. So don't make it like it's some brand new topic. It really is not. It's just a modification. So, example. You're given oxygen and fluorine. These are the two atoms. Now, right off the bat, we know that they are both non-metals. Okay, so that's going to be, because of that, it's going to be a covalent compound. Okay, so we know that. We know that. They're both non-metals. Lewis, I'm going to start by drawing the Lewis structure of each of these, okay? And it's important to do it this way. Oxygen, and this is called the four-quadrant method. I'm going to draw my little crosshairs there. Fluorine. Draw my little crosshairs here. Okay? All right, so now we're looking at this, and we've got oxygen and fluorine, and I want to be able to diagram the electrons for each of these. Okay, so I'm going to use red for oxygen, and the way this works is very simple. You've got, since for both oxygen and fluorine, they need a stable octet. I've got 4 quadrants, and therefore the ability to have 8 electrons in 4 pairs. And watch how this works. If I've got oxygen is in group 16. It has 6 electrons in its valence shell. You put 1 electron in each of the 4 quadrants, and then you start pairing them up after you run out of quadrants. Okay, I've got 1 in each of the quadrants. Now I have to start pairing them up. 5 and 6. Good. So it looks like oxygen has 2 pairs of electrons and 2 electrons that are not paired. All right, and that's the way that structure works out. Well, let's do fluorine. Fluorine, I'm going to use blue. Okay, fluorine is in group 17. It has 7 electrons in its valence level. I think looking at oxygen, you should be able to see what this is going to look like. 1, 2, 3, 4, 5, 6, and 7. So it looks like fluorine has 3 of the pairs and only 1 little unpaired electron there. So starting with that, these are the Lewis structures for the 2 atoms. All right, so let's go to the next slide. All right, so we have oxygen. I'm going to undo that, go back to black here. Oops. Let's just erase that. All right, so let's go oxygen. Remember, it was these pairs, and then these unpaired electrons for oxygen. Fluorine. Fluorine, and instead of drawing, because sometimes you're going to have a piece of paper, instead of drawing different colors, you're welcome to use different colors. I'm going to use little X's for fluorine's electrons just so that I can differentiate them. And watch, I'm going to, have pair, 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 and then a lone electron right there. All right. Notice how I lined fluorine's lone electron up next to oxygen's lone electron. I'm going to circle those two. Now look what happens here. Because this electron from fluorine and this electron from oxygen, they're both needing a partner. So since both of these are nonmetals, they both want to get electrons. Why? Because clearly fluorine wants a partner for its electron, oxygen wants a partner for this electron. So they both want them. Since they both want them, the only possibility is to share. All right. So now we've looked at saying, all right, if fluorine shares that electron with oxygen there, then fluorine is going to be able to count that electron, both of them, for itself. And then you get 2, 4, 6, and 8 around fluorine. And fluorine is going to be very happy with its octet. Now oxygen can also count these two electrons to itself, so it has 2, 4, 6, and then it's got this seventh one over here. It's going to have to do this sharing thing again in order to make itself happy. So the only possibility now is to say, well, in order to make a compound, you're going to have another fluorine. All right, I think you can see how that would work. So let's go ahead and look at this. I'm going to take this over to the next side and finish it off and say, well, I think you can predict that the way to do this is to say, all right, looks like oxygen's going to be, it's going to have these pairs of electrons, and has this electron here, and then I'm going to put this X for fluorine's electron, and I'm going to put fluorine right there. Like that. Okay, notice I'm indicating that the two electrons there, one of fluorine and one of oxygen, are being shared right there in the middle. Okay, now since, oops, and I'm sorry, I forgot to draw oxygen's other electron right there. Oops. Now obviously we're going to have the same thing going on for this electron, right? So I'm going to draw another fluorine with its electron, like this, and indicate that these electrons are being shared. So now we've got these electrons being shared, these electrons being shared. Because they're shared, I can count them for both atoms. Let's check our octet. 2, 4, 6, 8. Oxygen is happy. Let's check fluorine. 2, 4, 6, 8. That fluorine's happy. 2, 4, 6, and 8. That fluorine's happy. Everybody's happy. The only thing I need to do now to complete this is to say that any time you have electrons that are being shared between two atoms, it's represented as a single line. So shared electrons are called bonds. Okay, this is what an actual bond is. We didn't have bonds in ionic compounds. Okay, and the way we are going to demonstrate that is with lines. Every 2 electrons is worth 1 bond. So I'm going to add. And if we have the oxygen here, we have these pairs of electrons, like this. And then you had oxygen's electron and fluorine's electron. It's a single line that we're going to put between fluorine, and we're going to keep the rest of those electron pairs out there. We're going to do the same thing on this side. Oops. And like that. And so now we have every bond, okay, 2 electrons shared is 1 bond shown by 1 line. So this line represents 2 electrons, so does this. Sometimes you're going to end up with instances where you will see compounds that will have 2 lines between atoms, and all that is if there are 2 lines, that means there's 2 bonds, and if there are 2 bonds, it's 2 times 2 electrons, which means 4. Atoms don't have to share just 2 electrons. If they want, they can share more than that. But for this compound here, that's the way you would draw the Lewis structure. Anytime atoms are sharing electrons, you need to indicate that with a single line for 2 electrons, and if the case arises, then 2 lines if it's more than 2 electrons, like for 4 electrons. All right. Again, use the to summarize. what we covered here. It's very important. Use the 4-quad method for Lewis. Okay, remember, an example, that's oxygen. Remember, you draw the quadrants. 1, 2, 3, 4, 5, 6. And that equals oxygen with the pairs over here, and then these unpaired electrons in the other quads. Okay, and so that's how you draw the Lewis structures in order to get the right shape. Okay. 2. All right. Figure out how many of each atom needed to satisfy noble gas rule. Okay, so in the previous example, it took 2 fluorines and 1 oxygen for everyone to be satisfied. Okay, 3, use lines to represent bonds. 1 line equals 2 electrons. Okay, so this is the summary of what we've gone over. Okay, and you'll build upon this. And remember, use these rules and you'll be just fine. It's very, very, very similar to what you were doing making the ionic compounds. It's just got a little bit of a twist in terms of using the shared electrons and representing them as bonds, but otherwise pretty much the same thing. All right, good luck.